we've got an inequality, which means it's a less than or a greater than. So we're going to end up with either an OR graph or an AND graph. So we're either shading in between or we're shading outside. So the first thing we're going to do is find the critical values, which are the solutions, roots, x-intercepts. This one is already factored, so it's really easy to find where the x-intercept would be, or the solution. It's always the opposite of these. Okay, so I would call these the critical values. Critical values. And they are -1, so that will give me 0, and +2. All right, so open or close circle on those numbers based on this lovely thing right here. So since it's strictly greater than, this would be open circles. So I'm going to put open circles on -1 and +2. What this does is we're splitting the number line into 3 sections. So I'm going to draw kind of a dotted line here. And we want to know, are these numbers a solution, are these numbers a solution, or are these numbers a solution? We have 3 regions. And so we're going to test a point within each region. So a good number to pick over on this side, and we can't pick the critical value. So probably the next easiest number is -2. And we're going to plug it back in and see if we get a true statement. Is it greater than 0? So I'm plugging in -2 for x. Right here, plugged in -2, plugged in -2. So -2 plus 1. All we care about is this positive or negative? We don't need actual values. So is -2 plus 1 positive or negative? It is negative. Is -2 minus 2 positive or negative? It is negative. And so is a negative times a negative positive or negative? Positive. And so we're looking for numbers that are positive here. So yes, we're going to get a number greater than 0, which means that this region is a solution. So since this is greater than 0, yay, you're a winner. All right? And we're doing a domain of real numbers, so we can go ahead, whoops, and shade left. That's not very straight. Now let's test a point in between the 2 critical values. So a really good number to test would be 0. You should always try to use that one if it's available. I'm going to test 0 on the next one. So I'm going to plug 0 in right here for x. So 0 plus 1. Plug 0 in for this x. So that's 0 minus 2. This gives me a positive value. This gives me a negative value. A positive times a negative is a negative. And we're looking for numbers that are greater than 0. So is a negative number greater than 0? No. Okay? And so now we have to test another one. How about 3? So I'm going to test 3. Plug it in here. Again, you can do this in your head once you get better at this, right? So I'm going to plug in 3. Do I get a positive or a negative here? Positive. And I'm going to plug in 3. Do I get a positive or a negative there? And a positive times positive is a positive. And yes, that is greater than 0. So we can shade these values. We got an OR graph. Okay, one more thing. Notice this symbol is greater than. Okay, greater means an OR graph. Right. Another thing I want you to think about is this is actually a parabola, right? We have a quadratic equation. So if you think of this as a parabola, the solutions outside of the parabola are solutions in this case. Okay? But you don't have to draw a parabola on your thing. You just want an and graph or OR graph. Okay, so x squared minus 3x is greater than or equal to 4. This time we have a domain of integers. So a couple different things to think about. First thing we have to do is set it equal to 0 and factor it. So we've got x squared minus 3x, subtract the 4 to the other side, and now we're going to factor it. Okay, so what are the critical values? Okay, 4 and negative 1. And are we going to have open or closed circles if we've got the line underneath here? Closed. So I'm going to go ahead and put closed points on 4 because we are including 4, and negative 1 because we are including negative 1. And then I'm going to put my dotted lines on here, so we're breaking this number line up into 3 sections. When you test a point, it is easiest to go back to the factored form, all right? It does work if you go back to the original equation, but let's get used to doing positive times positive, negative times negative, and look for whatever we're looking for, right? So in this problem, we are looking for positive numbers because this says greater than or equal to 0. So it's true if we get positive numbers. So a good number to plug in would be like negative 2, all right? So now I'm going to test a point. And if I plug in negative 2 right here for x, do we get a positive or a negative? Okay, we get a negative. And if I plug in negative 2 right here, do we get a positive or a negative? We get a negative, and a negative times a negative is a positive, so this is true, okay, because we're looking for positive values. Now, this domain is integers, so for this particular problem, it's true in this region. So we need to do points, integers, and our darker arrow showing it goes forever negative. No matter what number you plug in, it's going to be a true statement. Okay, so then we plug in 0. So if I plug 0 in right here, do I get a positive or a negative? Get a negative. And if we plug 0 in right here, positive or negative? Positive. Okay, and a negative times a positive is a negative, so the middle is not true because we're looking for positives. Okay, and then on the last one, we could throw in 5. So plug in 5 for the first part, positive or negative. Good. And for the second part, positive or negative when we plug in 5. Yep, so we get a positive times a positive, which is positive. So we need to do our integers going this way. So again, we had a gray tour then, and we ended up with an OR graph, just integers. Again, know that you have to know open or closed based on that line underneath, right? Okay, so let's try some less than graphs. What do you think less than graphs are going to make? The middle part, right? The and graph. So we're probably going to shade in between. So let's check and see. This one's factored for us, which is nice. So max, what are the critical values?
Negative 2 and 3.
Good. So CVs are negative 2, positive 3. Okay, and Zach, open or close circles on negative 2, positive 3. Good, because there's a line underneath here, closed. So we've got negative 2, positive 3. Again, this is splitting it up into 3 regions, and we're going to test within each region. So we're going to plug negative 3 in first. Okay, so if I plug in negative 3, Kevin, positive or negative here? Negative. And if I plug in negative 3, Daniel, positive or negative here? Good. And a negative times a negative is a positive. Now, notice what kind of values are we looking for? If it's less than or equal to, which ones are solutions? Right, if it's less than or equal to, we're looking for negatives as solutions. So is this region a solution? No, because we're going to get all positives when we plug in these numbers here. Okay, so now let's plug in 0 to test the middle section. So if we plug 0 in here, Devin, what do we get? Positive or negative? Okay, and Patrick, if I plug 0 in here, what do I get?
Negative.
Good, so a positive times a negative is a negative. And this time, negatives are true, right? We have less than or equal to, so again, negatives are true. My domain is real numbers, so we would shade this region Okay, and I do want you to show me that you tested all the regions. So if we plug in 4, we get a positive times a positive, which is a positive. Okay. So for less than, we're looking for negative solutions. Greater than, we're looking for positive solutions. Everyone pretty good with that? Okay. All right, let's try one more. Less than. First thing we're going to do is set it equal to 0. And Cole, how does this factor?
X minus 3 and x plus 1.
Good. And Alex, what are my critical values?
3 and 1.
Close.
Negative.
Good. Okay, 3 and negative 1. And Carrie, should I put open or closed circles?
Open.
Yes. And actually, with this one, we don't really need the open circles. It's integers, right? So we would leave it blank. So let's just put our lines right there on those critical values. Since it's integers, there's not going to be a circle there, okay? And we're going to test a point. So I'm going to test negative 2. So David, if I plug negative 2 in right here, positive or negative?
Negative.
Okay. And Kendra, if I plug in negative 2 right here, positive or negative? Good. And a negative times a negative is a positive. Are we looking for positive or negative answers? Yeah, we're looking for negative answers here. All right, so let's test 0. So if I plug in 0, what do we get here? Okay, if I plug in 0, what do we get here? Positive. So that gives me a negative answer. So my solutions to this one are only 0, 1, and 2, right? Because this would give me positive, positive, positive. All right.